Hello everybody. Now we'll be discussing the physical significance of electric flux. For this, let us again start with basic description of electric field using electric lines of forces. These are three figures. This first figure shows that the electric lines of forces, they are very close to each other. So this represents a strong electric field. Here the density of lines has reduced. Obviously it means strength of electric field has reduced. Again come to the third figure. Here the strength of electric field is still lesser because the lines are far apart. So this rough description of electric field strength using lines is clear. If lines are close, as in this first case, electric field is strong. If lines are further apart, electric field strength decreases. If the lines are still further apart, electric field strength decreases much more. So from here we can conclude that electric lines of forces, the strength of field can be represented by the density of lines of force, or we could even say that density of this lines of force is proportional to the field. Means more denser the line, more stronger is the field. So density of lines is proportional to the strength of field, or the electric field strength is equal to the density of lines. Now we will take the proportionality constant as 1, and this conclusion we can draw, that electric field intensity is simply equal to the density of lines, number of lines per unit area. Now come to another case. Here we have an electric field represented by these lines of forces, E in the horizontal direction, and we have a surface having normal in this direction. Now let's see something which we will be calculating over here. We'll try to calculate the number of lines passing through this surface. Number of lines passing through this surface can be written as density of the lines into area of the surface. Density of lines is obviously electric field intensity, we studied it just now, into area, or E into S, electric field E into area S. We have already studied that electric field into area is electric flux. So our conclusion is number of lines passing through a surface is equal to flux through the surface. So here we have a physical significance for this electric flux. We can say that electric flux through any surface is the number of electric lines of forces which are passing through the surface. If more lines are passing through the surface, it means that more is the flux. If lesser lines are passing through the surface, lesser is the flux. Now here, although we have arrived at this generalization by some special case, but this rule or this physical significance of flux holds for all cases.